which I'll go into more detail about that later. And also included is a program where you can train your own custom poses to be recognized by my classifier. And then a package for the Unity 3D game engine that developers can easily drop into their projects and then start using the software right away. The origins of this project are that I thought that the Kinect was really awesome when it came out because forever people have been looking for this great motion tracking technology, and the Kinect it finally makes it cheap enough that the regular person can use it in their personal projects. And basically the Kinect SDK that Microsoft releases gives access to the raw data that the Kinect can track, but there isn't really any standard implementation to process the data that we're given. So what professional game companies do, because with the Kinect there's tons of different possibilities and there's tons of different ways to interpret the data. So in this example, you have this game on the left, your left, yes. This game on your left, where basically what they're doing is doing a real-time tracking of the hands and the feet, and they're just checking for an overlay between objects and the player's hands, which is very different than the game on your right, which is it's a screenshot from Dance Central 3, and this game is basically looking for poses at different time steps, and it's measuring the error in your pose and then scoring you off of that. So these are very different approaches to different games that use very different styles of interpreting the data. And professional game developers, they have the time and resources to make their own custom implementations for their different goals that they want to achieve. However, for the rest of us, a lot of times you're a student, or maybe you're an amateur developer who has another full-time job, and you don't really have time to make your own custom implementation. And maybe if you do start, you have a really great idea and you start making your own implementation, by the time you get done with your implementation, you may not have that passion or that burning desire to make this idea that you used to have. And then, so I believe that I'm of the opinion that developers should direct their efforts towards innovation rather than messing around with just tons and tons of code just to get their ideas kind of into a realizable state. Okay. So that leads me to my project goals, which I wanted to create a program that runs for the Unity 3D library, or game engine, that allows the user to easily recognize a library of poses. And I wanted to make it easy for developers to train their own new custom poses because you never really know what your developer is going to want to do in their projects. And then also I wanted to include just a kind of bread and butter standard library of generic poses. And then you may ask, why do you like this Unity 3D game engine so much? And this is a great up-and-coming game engine. It's cross-platform, but the Kinect SDK isn't really cross-platform, so it doesn't really matter that much. But it does have a very robust free version. It has a cheap pro version for students, which is one of my main target audiences. It has a really great online community and excellent tutorials for amateur developers, and then also it lends itself well to extensions like mine. So now to kind of get into more of the guts of the program, this is how the Kinect sees your body. Not this exactly, but something like this. Basically, it tracks the different joints in your body, and then it'll give you their position in 3D space in X, Y, and Z coordinates. And that's basically all that we're going to get for free. The Kinect doesn't do any other kind of processing on this. So we can look at these different coordinates in 3D space to kind of recognize what poses that people are performing. And you may at first think that it would be best to compare different transforms, but actually because of height and weight variations, people's joints are always going to be in slightly different configurations. So the way that I approach this is that it's best to look at angles between joints. Because if a tall guy is doing this and a little girl is doing this, this angle is still going to be 90 degrees. So that's how the pose representation works, is that each pose is a set of angles between specific joints. And then here, these are basically all of the joints that the Kinect can track. And like I said before, the pose is a set of angles between joints, which I call features for purposes of this project. Anyway, So for any given pose that we want to train, we have to give my program a lot of different instances of this pose being performed. And we want to have people, because we're doing angles, like different body types shouldn't matter, but really it's best if we cover all our bases, have lots of people perform this specific pose that we want to generate. And then we're going to use all this training data to extrapolate future instances of this pose being performed. And that's where the naive-based classifier kicks in. This basically is used to generate the probability that a pose is being performed for a set of many features. So what we want to do is for our set of training data, we want to find the mean and standard deviation of all that data for the angle of this feature. So if my pose was like this before, basically I'm going to go through all my instances of this pose being performed and look at this specific joint. And for every instance of this joint, I want to find the mean and standard deviation. And then I plug in, And then I plug into my equation here, and that gives me the probability that this angle in my current pose that I'm looking at is, or how likely it is that is the angle in my training set of poses. And then at the end, I'll have X many probabilities for however many features I'm tracking, and then multiply them all together to get my total probability that this pose is a given pose. So basically, because we're multiplying probabilities together, we get very, very small numbers in the end. In my system, we track 13 separate features. So even if you have a 90% chance that one feature is going to be your given feature, you're multiplying that 0.9 times 0.9 to the 13th. So we get numbers that are millions of fractions, basically. And then sometimes you get a problem where the pose recognition will fail because of an irregular feature. So in this example, these people are doing roughly the same pose, and we want it to identify as the same pose. But if you look at the legs, this person's legs are at more of an angle than this person's. And really for this pose, we don't even care about the legs at all. All we care about is this arm and this arm here. So to improve my project, that led me to developing a system of joint masks. And basically what a joint mask does is that I can mark different angles as being relevant to a given pose while I'm training it. So then I'll just throw away some of this data that I don't care about. So for this pose, for some reason, all I care about is your left arm and your right leg. And then this works really well when you have poses that have the same number of tracked joints, because you can reduce all this different noise data. Even if the joints aren't exactly the same, we just care about how many fractions we're multiplying together, and then we want to have some kind of comparable number in the end. It doesn't really work very well if you're comparing a pose like this to a pose where all of the data points are on, because then obviously this probability is going to be way higher than the other one, even if the other one would read off as being closer to the track pose. So because this system is primarily intended to be used in game systems, I wanted to make sure that I could achieve interactivity rate frames per second, or frame rate, I guess. And actually, the most expensive part of the process is pulling the Kinect skeleton and then comparing. Let's say I have 1,000 trained poses that I want to compare against. Comparing that every frame for X many features gets to be really expensive over time. So kind of a way that we can streamline and optimize this is that unless we have a pose classified, we'll keep on trying to classify. And then once we do find a classified pose, we're going to wait a few frames, which this is really easier to find for the different game that you're building. So if I say, okay, well, I'm doing this pose, I'm not going to expect my user to move their body all some other way within a fraction of a second. So I want to wait a couple of frames before I'm going to try to classify again. And then that relieves a lot of the load of the program. So now some examples of kind of ideas that this would be really suitable for. This is a game called Human Tetris. It's a popular game show in Japan. And basically the idea is that you have all these walls, and the walls have these human silhouette kind of holes cut into them. And the user has to get into this position to fit through the wall. So this will work well for classifier because you know exactly when you want to classify. So if the person is if the person achieves that pose at the time you want to classify, then you don't really have to poll again until the next wall comes up. And you don't really care what they're doing in between. This is Dance Central 3, and I think Dance Central 3 does use a system like this, where again, it's like every move is like a wall in Human Tetris, and you don't care about what they're doing in between. You only care what they're doing at these specific time steps. So that's the only time when you actually have to pull the skeleton. Also, fitness games would be good for this. This is used in a little different way. They're expecting you to be in this pose, and they only have one pose that they're trying to classify, but then they take the probability that your error from the pose, and then they instruct you on how to reduce that error. So a game like this, it could also be used for. So all this time I've kind of been talking about static poses and stationary poses. And maybe when you think about the Kinect, you think about someone doing a lot of movement and like moving around and doing moving gestures. So actually this wouldn't really be that too hard to achieve if you can see static poses, because really all a moving gesture is just a sequence of static poses. So basically the idea here is to train your start pose, your end pose, and then any intermediate points you want. And really the fewer the intermediate points, the better, because we're just working on probabilities here, and there could be a case where we could fail. So we want to kind of limit the possibility of failure here. And then you just you check to see if this sequence of start to end has been performed. And if it has, then you can mark that gesture as being performed. So this is an easy way to transition to moving gestures. And this could be used for fighting games where you want to see someone do a punch or a kick. This is a Dragon Ball Z game.
It's the only reason why I'm watching it.
So really, with this position, or with this system, your possibilities are only limited by your imagination and how well you can get the software to work for you. So now I'd like to receive any questions, and also here are my websites.
So have you looked at any ways of doing smoothing with the phase classifier so that you have, if you're comparing gestures with different features, different sets of features, you can more accurately compare those probabilities? It seems like there should be something in the literature that sort of describes how you do that. That can't be a problem that no one's encountered before.
Yeah, I mean, I'm sure that would be a good excision. I haven't really looked into that personally. Originally, when I started the project, I did want to do only moving gestures, and that's before I really thought to do Bayes. I was going to use a hidden Markov model, so I think that kind of system would be good for someone like that.
What's the sort of turnaround time on the skeleton capture?
Well, the skeleton capture, I'm not really sure. I think when I'm trying to capture every frame, I'll get around 15 frames per second. Which, I mean, it's not abysmal, but for games these days, you want to run closer to 30. So.
Sorry, this is fascinating stuff to me. Have you looked at any, so the gesture library stuff is interesting. It seems like with that, there's an opportunity to build something on top of that based on sort of kinematics and sort of what the human body is and isn't capable of doing, and using that as a sort of development environment for game designers. You looked at, or is there anything out there that sort of exists like that, or are you thinking about working on developing something that can help people say, well, I want to move from this gesture to this gesture? Is that even possible within the mechanics of my game?
I think that kind of sounds a little bit similar to mocap technology. I think the Kinect would be really useful for mocap. One thing you could use, or one early idea I had that I never really explored, is that you could use my system for building animations from human movement. And then if you're building an animation that way, then you don't really have the problem of having like an illegal joint movement, like someone could bend their elbow backwards, and you wouldn't capture that kind of data in the first place. That kind of
I think so. So I mean, so when you go to actually design a game, there's a certain desire. You're trying to get that. It's challenging, but not so challenging that it's frustrating. And being able to sort of find that space where you can, I forget what the guy's name is. It's
Like the rubber banding between difficulties.
Yeah, and so like there's this idea that you kind of want to be sort of in the middle in order to
Oh,
like,
6 cents a month.
that's the one. And so I guess I was wondering, it would be interesting to sort of incorporate some of the gesture stuff associated with some of the kinematics and some of the cognitive science stuff, and sort of try to start building an SDK that allowed game developers to sort of know these are the things that are possible with human movement, and sort of interacting with them, tightening the loop, so to speak, so that they can actually create games that are more interactive and less this sort of like take a snapshot, are you in this position, take a snapshot, are you in this position.
Yeah.
I don't know, it just sounded interesting.
Yeah, I think that's definitely interesting.
More questions? Nope.
Right.